Yeah, holy hell. I think I'm caught up with all my emails.
Sir,
What?
um, I had just gotten back into Canvas, so I am barely catching up on all of the Pearson information.
Okay.
Um, do I need to email you for the code to get in?
Well, hang on a second. I will show you some things.
Okay.
Okay, you should see my screen right now, right?
Yes, sir.
Okay, my Zoom totally disappeared. I don't know. Okay. So first thing you do is you try and go through modules.
Okay.
Do you have yours up?
Yeah, when I try to click on modules, there's nothing beneath that red shelf thing.
So it's not here.
Yeah, it doesn't say anything.
So go to My Lab
Okay.
and sign in through there, and there should be a link for temporary access.
Okay.
Okay. And you will get an email from me. I think there's a couple of people in class who've already gotten an email from me. I think it's an ACES email, because they automatically use your ACES email for this. So a lot of times when I send out mass emails, I send it through ACES. Yeah, through Pearson, because everybody signed into it. What was I going to say next? Oh, and so yeah, they're sending me. I'm letting them know how many students I need access codes for, and they're sending me the access codes, and I email them out. And that's what I've been doing today. I emailed out. How many did I email out? I emailed out 13 emails so far to students who need the codes. And that's for people I already knew who needed the codes. And the way I knew that is that they had temporary access. So sign in and get temporary access. And if you can't get temporary access, I think I have one person who cannot. For some bizarre reason, it's not showing up on their screen with whatever hell that machine, whatever hell that they have a Mac. And when they sign into Pearson, when they trying to sign in through Pearson to get the temporary, it doesn't show up there. Okay.
Sir,
Yeah.
when I go on the modules page, there's the link there doesn't take me to anything.
I can barely hear you. Hang on a second. I think my volume is in the, yeah, okay.
I put it in the chat as well.
Oh, it helps if I open up my chat window, doesn't it? Here we go. Okay. All right. If it's empty for you, then you go straight into My Lab and try and sign in through there. Get the temporary access through there.
So the assignments are in the math lab, and then the books in Pearson, right?
Yes.
Okay.
It's the Sullivan Pre-Calculus Edition 11, the 11th edition. Tyler, I sent you the code, and one other person in this class who has temporary access, I sent the code to. Y'all get an individual code. So if you get a code, that's your code. Don't tell someone, oh, I got a code here, use mine. No, it won't work. Can't do that. I don't know why, but they want to keep track of who's got what code.
Wait, so should I get the code for the 14-day temporary access?
Yes, that way you're in there already. That way you're in there. And you can be doing the work. And then I can get you full access once I get the code for you. Is that making sense?
Yes.
Okay, cool.
The first chapter is like graphs, right?
Section, what is it? 6.1, right?
Let me check.
Yes.
Cool. And I have not done this yet, so I'm going to pull this up. And I have to do this. I have to get my tablet ready. Oh man, I was so sending emails and clicking links. And wasn't able to get everything ready like I wanted to. Right now I'm getting my tablet ready for y'all. Hope everybody's signing in.
So we can do some of these ahead of time, right?
Oh yeah. If you're able to work ahead, then work ahead. I have no problem with that.
With our tests, are we gonna have time limits?
Yes.
Is it an hour?
The class is an hour and 45 minutes. I mean, an hour and 40 minutes. So the exams will, that's basically how long you have to take the exam.
And usually, how many questions do they have?
Let me see, 15 to 25.
Oh, okay. And are they multi-step, like part A, part B?
Some are multi-step. That's why I don't have a whole lot of problems on a test. The more multi-step problems I have, the fewer number of problems you have. So I like problems that cover several concepts. So if I have a problem on there that covers 4 or 5 different concepts, you might have 2 problems like that, rather than having 5 or 10 problems that cover all those, that covers all that material. So a lot of times it just logically goes through. Wow. You remember doing difference quotients?
That was a while back, sir.
Yeah, that was college algebra. And yeah, when you get into calculus, you're going to see that again. The reason I brought it up is that's what we're doing in my college algebra classes right now, is the difference quotient.
I would just need like a little refresher, but I remember, I'm sure.
Yeah, and yeah, you'll get it big time in calculus. Calculus is it starts out with Newtonian physics, which is finding the derivative. And finding the derivative, you need to know what limits are. And so calculus starts out with explaining what limits are and how to calculate limits. And then the what did I say that was? the difference quotient. And once I get things cleaned up here, I'll show it to you. Has everybody signed in? So, with the difference quotient, you end up taking the limit as h goes to 0. And since h is in the denominator, or actually in calculus, I think we get away from using that notation, start using the, come on, behave, you silly beast. All right, let me see here. Come on over here. Here we go. All right, you see my grid, right? The difference quotient is, oh man, I gotta have the pen back, is f of x plus h minus f of x divided by h. Anybody remember seeing that?
Yes, looking very familiar now.
Yeah, that's actually the slope formula. You have 2 points, x and x plus h. These are 2 x values, and this one is h units away from x. And so f of x is y, so you have x and y, and then you have and then you have x plus h, and then you have f of x plus h is the y value for that x. So instead of using x and y, I'm going to x and x plus h, I'm going to use x sub 1 and x sub 2. And so this is going to be y sub 2. So f of x, or f of x sub 1, is y sub 1, and f of x plus h is f of x sub 2, which gives us y sub 2. And so here we have y sub 1, y sub 2 minus y sub 1. And to get this h here, well, then that's the x values, x sub 2 minus x sub 1, which is x plus h minus x, right? And x minus x is just h. And so h is that distance between the 2 x values.
Yep. Now
So
that
this-
one's super familiar.
So this is just slope. And you'll see that very clearly in calculus. If the professor doesn't make it obvious, then I don't know what to say about them. But we want to know what happens when this second point gets very close to the first point. So what happens as I bring x this way, in other words, that distance h goes to 0. Well, I can't divide by 0. So what I do is I simplify this formula. Once I know what f is, I can simplify this formula, and then I can take the limit of h, and that'll give me the derivative. It's the limit definition of derivatives, which I gotta tell you, it can get awfully complicated depending upon the function. And there are shortcuts, and you'll be taught the shortcuts. But you're also expected to know how to find the derivative using the limit definition. Okay. What am I doing now? Oh, any more questions about MyLab? And what you're required to do there? Yeah, I sent out that semi-rude email telling y'all to get into to my lab and try and get it working. And if you do not have the red shelf access, then you need to get in and do the temporary access and email me that you're in there through the temporary access so I can get you the code. And if you can't, I've had at least I've had one person tell me that they can't get temporary access because it doesn't show up on the page it's supposed to. So in that case, you have to send me an email so I can get you the access code.
Okay.
And so 2 people in this class who have signed into my lab are through the temporary access, and I've already sent them their codes. Now, what they used to do in the past, there was one code for all. Everybody who's taking pre-calculus had the same code. Well, they've changed that. Now you have to get your own code to log in to use. And so that's what the red shelf is. So it gives you a unique code. And so if you cannot get one that way, then I get one. My department head emails me these codes and I send them out to you. And so the code you get is your code, nobody else's. What else? Okay. For those of you, what?
Who's the author?
Sullivan.
Okay.
And it's the 11th edition of pre-calculus. Now, Sullivan has a lot of textbooks and a lot of college algebra textbooks, but I think he's got a couple of pre-calculus ones as well. But yeah, this is the one we use. We've used the previous edition. As a matter of fact, I think I mentioned that the PowerPoint I use is I'm trying to do 2 things at once here. I'm sorry. The previous edition was the 10th edition, and that was the PowerPoint I used to use, but they updated the PowerPoint and it has some issues. They updated it and then they made notes in it. The editor made notes in it and the person who was writing it didn't complete the notes. And so there's mistakes. So we're going to have to deal with those as they occur. Okay, I'm trying to figure what I'm doing right now is trying to figure out where we left off.
Where did we leave off?
I thought I was building the unit circle.
Looks like you were showing us 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and then their points. Their plot points like 1/2, that kind of
Yeah.
stuff. And you showed us like that little trick on how to get them. You put the 1 and 2 and then the 3 and then the 2 and then the
Yeah.
1 and
Okay, we'll get, that's what we'll start with. So that's not where I wanted to be. Come back to here. And so the PowerPoint slide I'm going to start with is the one with the quadrantial angles. So I'm going to spend a little bit here setting this up so we can get going. Oops. Pull up that silly thing. There we go. Put that back up there. Come over here. Where's the zoom? I lost my zoom. There we go. Zoom gets hidden behind a bunch of things I'm working on to get. Thankfully, I have two screens, and so. Here we go.
Great.
Now, yeah, we talked about those and that each point in the, I'm gonna turn this on so I can see what I'm doing. I'm sitting here in the dark. Oops. Wow. Oh, I forgot. Okay. Big old shadow there. So we have the 0 degrees and 90 and 180 and the 270. Those are the quadrantial angles. And this is 0 radians as well as 0 degrees. And oh yeah, I got to put the. So, and this is pi over 2 up here, and this is pi over here, and this is 3/2 pi. Halfway between here and here is 45 degrees. And so then we have the 45-degree angles. We have 45 degrees and we have, what is this? 135. I add 45 to 90. And then the other 45-degree angle is over here, adding 45 to 180 gives you the 225. And then adding 45 to the 270 gives you, where is that? 315 degrees. And then you have the 30-degree angles. So that's 30, and adding 30 to 90 is 120. And 30 to 180 is 210. And 30 to 70 is, what is 30 and 70 is 300. Now to get the 60-degree angles, there's a couple of ways of doing it. I just add 30 to 30 and that gives me the 60. So I add 30 to 120 and that's 150. I add 30 to the 210 and that gives me 240. So these are multiples of 60. And then I add 30 to 300, which is 330. Okay, and then this is 360. Now, the issue becomes, what are these in pi? Well, you can multiply by pi over 180, or you can learn that this is pi over 6, and this is pi over 4. It's a fourth of, it's 1/2 of pi halves. And then this is pi thirds. The 60-degree angles are 1/3 of this distance of the 1 pi. So it's 1/3 of pi. And over here we have 2/3 of pi. So that's 2/3, not 23. 2/3 of pi. And so another 60 degrees is to the pi, and then another 60 degrees is here. So that's another third beyond the, so we can think of this as 3 pi over 3. So this is going to make this 4 pi over 3. And then the next 60 degree is going to be at the 300. So I'm adding 2 more thirds. Well, just 1 more third, actually. 1 more third brings us to 5 pi over 6, and then, I mean, over 3. And And then another third brings us back to the 360 pi or the 2 pi. And then the 30-degree angles, well, what I consider, well, the 60-degree angles are 30-degree angles, but these 4 angles here, all right, so you notice the symmetry here. This is 1 less than 180, so this would be 6 pi over pi. So 1 less than that is 5 pi over 6, and this one is 1 more than 6 pi over 6, so that's 7 pi over 6. And so you come over to this one, it's same deal. It's one fewer than 12 pi over 6, which is 2 pi, and you get 11 pi over 6. And I have just found it's easier just to memorize those rather than trying to figure out a pattern there, because there is a pattern, because all these angles here are symmetric. Okay. They exhibit symmetry, and the symmetry is also shown in the ordered pairs. Okay, and to show that symmetry in the ordered pairs, let me go over to the next page, and we can build this thing up. Okay, we can build this thing up. We have the 0 degrees, and then we have the 30 degrees, and the 45 degrees, 60, 90, and then 120 degrees. I did one of these one time, and I totally skipped some of them. It's when I was running through it. Not in class. Boy, I did a big no-no in class, in my other pre-calculus class yesterday morning. This is 225 because it's one of the 45-degree angles. And then this one is 240 degrees. And then we have 270 degrees, and then the 300 and the 315 and the 330. What? I skipped something. What did I skip?
Did you, sir?
Huh?
Did you? Are you asking or are you telling?
I did.
I knew it. I knew it. I said I need to leave spaces because knowing Reed, he's gonna miss one.
So 150, I forgot that there's that. Actually, wait, 120, and then 135 degrees, and then 150 degrees. So I missed those 2. And then we have 180, and then we have 210, and then we have 225, and then we have 240. The 3 angles in here, there's a difference of 15 degrees between 30, 45, and then another 15 degrees here, because that's 30 degrees from the 30 to the 60. And so the same thing over here with these 3 angles. And then we have 270, because I noticed I was going to have more space down here. Than, by the way, this worksheet should be, or it is in what do you call it? In Canvas under Files. And so then we have the 300 degrees and the 315 degrees and the 330 degrees and the 360 degrees. I can write it right. Now, the radians, well, we have 0 radians, and then we have pi over 6 radians, and pi over 4 radians, and pi over 3 radians, and then pi over 2 radians. And then it's going to be 2 pi over 3. So the numbers in the denominator start decreasing, start doing the reverse. So the denominator, so this one's going to be a 4 here, and that's the next one, which is 3. And then this one's going to have a 6 in the denominator because it started at that, and it's going to be a 5. And so then we have pi. And then the denominators start doing the same, but in the reverse order that they're there. Well, actually, yeah. And so we have pi over 6, so that's going to be 7 pi over 6, and then pi over 4, and that's going to be 5 pi over 4, and then this one's going to be over 3, and that's going to be 4 pi over 4.
Sir, are you writing?
It's not showing up.
No, sir.
Ah, damn it. It's done that. Maybe it'll show up now. There it is. Okay.
Mhm.
Boom, it all came at once.
Yep.
And this one is a quadrantial angle. So it's 3 pi over 2. And then the next one starts with 3 in the denominator again. So it's going to be 5 pi over 3. And then that's going to be 4 or 7 pi over 4.
Doing
This
it
is
again,
going to
sir.
be 6, which is 11 pi over 6. Oh, it's doing it again. I don't know what's
it
making
again.
it happen that way.
Sir, it's those other things you got to open. You got to close them out.
What? No.
I'm just kidding.
And then you have 2 pi at the bottom. Now the quadrantial angles, right? The quadrantial angles we're talking about, those have specific degrees, specific points. Okay, so like we're looking at this point here is 1, 0, because that's the x value is 1. That's the radius. The radius going up this way at this quadrantial angle is also 1, but it's the length of the y. So that's 0, 1. And over here at this quadrantial angle, again, we have the radius of 1, but we're going in the negative direction in the x direction. So that's -1, 0. And same thing down here, but it's the polar opposite of 1, 0, of 0, 1. So it's going to be 0, -1. Okay. And so we can build our start filling out our chart at the quadrantial angles. Too much crap on my desktop. And so this is 1, 0, and then 90 degrees is 0, 1, and then 180 degrees is -1, 0, and 70 degrees is 270 is 0, 1. That's 3 halves pi. And then at 360, we're back to the origin. We're back to the beginning.
Sir,
Yes.
I thought 0 degrees was 0, 0.
No, 0 degrees is 1, 0. Here, we'll show you. Zero degrees on the unit circle. So on the unit circle, we only have one. We only have, we don't move in the y direction, but we do in the x direction. So that's 1, 0. 0, 0 is this point here. That is not on the unit circle. So this point here, it's not showing up. There we go. This point here is not on the unit circle. We're talking about the coordinates on the unit circle.
Yeah.
Okay. Now, there's going to be fractions for all of these missing coordinates over here. And they're all going to have 2 in the denominator. So I just do that one's going to be over 2, that one's going to be over 2. So I just fill all of these in. And then to fill in the numerator, I just count. I start in the y, and I go 1, and then I count to 2, and then 3 by going down. And then I go over to the x's down here, and I start here at 1 and 2 and 3. And then I take a square root of all the numerators. Square root of 3 is the square root of 3. The square root of 1 is 1. The square root of 2 is square root of 2. Same with this one. And then the square root of 1 is still 1. And the square root of 3 is square root of 3. I put in my commas and I put the parentheses. So there's those ordered pairs.
It's so tedious, sir.
Yes, a lot of mathematics is tedious because you're writing the same thing over and over again.
Mhm.
And that's why you have to be careful, because that's where mistakes happen, which is what I did the other. I switched my numbers here on my class the other morning. I did it in the I started in the tangent. I mean the x values 1, 2, 3 rather than the sine value. I mean the y values. Now,
Sir, you did that to us the other day.
what?
You
I
switched
told
it
you
around.
wrong?
Yes,
Oh.
I remember. I have it right here. I remember because you did do 1, 2, 3, and then 1, 2, 3.
Yeah, okay. So
Come on, Rick.
yeah, my apologies. I
Nobody's perfect, right, sir?
because, well, I'm so used to how I build these up, how I used to build these up. We using the 30-60 right triangle, where this is 1, no, this is 1, this is 2, and this is the square root of 3. And then the isosceles right triangle, where you have a 1 and a 1 and the square root of 2. 1, 2, 3, square root of 3, 1, 2, and square root of 2. And so, and then I look at cosine is adjacent over hypotenuse, where sine is opposite over hypotenuse. So that's how I would fill in that way. This is 30, and so the sine is 1 over 2, which is 1/2, and cosine is the square root of 3 over 2. Cosine is the x value, sine is the y value. And that's how I used to build these. Now you have to be concerned. This is all in the first quadrant.
Mhm.
Once I get out of the first quadrant, I have to be careful of the signs. In the
Okay.
third quadrant, they're both negative, where in the first quadrant, they're both positive. In the second quadrant, the x is negative and the y is positive, where in the fourth quadrant, the x is positive and the y is negative. But how I build those numbers are the same way. Okay. I just need to be careful what the signs are. So all of these are going to have, and I usually put a little extra space between them because I need to be careful where the sign goes. Now, the x's are going to be negative here because I'm in the second quadrant. So I have negative, negative, and negative. But in starting, and if I start counting in the sign going down, I don't start with 1 again. I start with the square root of 3 because of the symmetry that's involved. These coordinates here are going to be mirrored in this one here, except the x's are going to be negative.
So square root of 3, square root of 2, 1. on the
So
right
this one
side.
is going to be 1 and square root of 3.
Yeah.
And
Gotcha.
but these are the 45-degree angles, the 45, the 135, 225, and the 315 are all going to be the square root of 2 over 2 for both the x and y. It's just which quadrant am I in?
Mm-hmm.
And so this one is going to be square root of 3, 1.
Gotcha.
Now the next 6 are going to follow the same pattern as the first 6 because of the symmetry involved.
Sir, is every single one gonna be over 2?
Yes,
Okay. I mean,
they're
except for
all
those.
over
Yeah.
2.
Okay.
So all of these are going to be over 2. And in the third quadrant, they're both negative. So I'm going to write them as the negative halves. I'm going to go ahead and build that up and then worry about what goes inside. And so what goes in the numerator, the third quadrant has point symmetry with the first quadrant. That means everything's going to be identical except for their signs. The signs are going to be reversed. So that means this is going to be negative square root of 3, negative 1/2, because this is positive square root of 3, positive 1/2. And so this one's going to be negative square root of 2 over negative square and negative square root of 2 over 2 and negative square root of 2 over 2, because this one's positive of that. And so I'm going to do the negative of 1/2 and square root of 3 over 2. So it's going to be a negative 1/2 and negative square root of 3 over 2. And third quadrant is going to look almost exactly like the second quadrant, except the signs are going to be reversed. So all the x values are going to be positive, and all the y values are going to be negative. So I can build it up that way. I can go ahead and build my order of pairs before I start putting the numbers in the numerator. So this is going to be 1/2 negative square root of 3/2, and then square root of 2/2, and a negative square root of 2/2, and then square root of 3/2, and the negative 1/2.
Got it. Wow.
So
Mhm.
oh,
It's crazy. It's the same thing over and over again. We just
Yes.
change the signs.
yeah,
And
I'm just going to erase some of this stuff here. Well, you know what I'm going to do? I'm going to do it this way. Okay. So this point was 0, 1. And this one was square root of 3 over 2, 1/2. And this one was the square root of 2 over 2. And this one, the square root of 2 over 2. And this one was 1 over 2, 1/2 square root of 2, square root of 3 over 2. All right. Notice the symmetry between these two. And then this one was 0, 1. And this one starts these again in the reverse order than that they are here. So this is going to be 1/2 square root of 3 over 2, but the x values are negative over here, so that's a negative 1/2 square root of 3. And the next one's going to be a negative square root of 2 over 2. square root of 2 over 2. And then the next one's going to have the same x and y values as that point, but the x value is going to be negative, so it's a negative square root of 3 over 2 1/2, positive 1/2. And then this is a negative 1 0. Now I'm looking across here because of point symmetry. This point here and this point here are symmetric across the origin. So that means they're going to have just the opposite sign. So this one's going to be a negative 1/2, a negative square root of 3 over 2. Because its matching point up here is positive 1/2, positive square root of 3 over 2. Same thing here. It's going to be, its matching point is the square root of 2 over 2, square root of 2 over 2. But since it's in the third quadrant, these both are going to be negative. And this point, the same with this point. I'm going to have square root of 3 over 2 and 1/2, but they're both going to be negative because of where they are. They're in the third quadrant. Now in the fourth quadrant, these 3 points down here have point symmetry with these 3 points up here. So they're going to have the same x and y coordinates, except the signs are reversed again.
Yes.
So this point becomes down over here, and so it's going to be the square root of 3 over 2, negative 1/2, right?
Mhm.
The x value is positive over here, and the y value is negative. And then, so we're going to have the positive square root of 2 over 2 and the negative square root of 2 over 2 for this 45-degree angle, which is, what is this, 315 degrees, or 7 pi over 4. And this one's going to have these coordinates with the reversed sign. So it's a negative 1/2, not a negative 1/2. It's going to be a positive 1/2, negative square root of 3/2.
Mhm.
So there's all kinds of things that are happening in a circle. You have all kinds of different symmetry floating around. You have point symmetry, you have symmetry with respect to the y-axis, and you have symmetry with respect to the x-axis. And so all of these points follow that sense of symmetry. Okay.
Sure, it's a good thing to actually know these by memory, correct?
Yes.
I remember my trig class, they would give us this little it was that little square, and it was a good reference, but the idea is to actually get that down and to memorize it.
And then you start looking at it and you start seeing the things I'm talking about now. These 2 points have symmetry across the x-axis, which means that everything's the same except for the sign on the y's. So these 3 points and these 3 points have symmetry that the y values change signs. The x values stay the same. Same thing is true with these 3 and these 3. And the symmetry across the y-axis is that the y value stays the same, but the x value changes signs. So that little rectangles I was drawing shows you the symmetry of those points. And the x and y are all the same except for their signs in those 4 points, because it just depends upon where you are in the unit circle, what quadrant you're in. And so, well, the 45-degree angles, since x and y are the same value, it's just a matter of figuring out where you're supposed to be on the unit circle, what quadrant you're supposed to be. And then these sets of angles have that same symmetry. So I drew this again. And since x on the unit circle, the cosine of theta and the sine of theta are your x and y values. So the sine of 30 degrees, which is this angle here, the sine is 1/2, where the cosine of that angle is square root of 3/2. And so if I'm talking about 60 degrees, which is there, then the cosine of 60 degrees is 1/2, and the sine of 60 degrees is the square root of 3/2. Now the cosine and sine of 120 degrees, or 2/3 pi, are going to be the same as the cosine and sine of 60 degrees, or 1/3 pi, except the cosine is going to be negative now. So when they start talking about finding the exact value, all right, I think these we did already, because those are quadrantial angles. Yeah. So for 45 degrees, the 6 trig function, all right, so x and y for 45 degrees, the sine and cosine are going to be the square root of 2/2. That's the sine of pi over 4 is the square root of 2/2, and so is the cosine of 45 degrees is the square root of 2/2. And since tangent is sine over cosine, well, then that's just the same number over itself. So the tangent of 45 degrees, so I wrote 450 because I made my degree symbol too big, is 1, because x and y are equal. And so to find the cosecant, and I'm going to write 45 degrees for all of these, is 2 over the square root of 2, or 2 times the square root of 2 which is just the square root of 2. Yeah. Because what do I multiply the square root of 2 by to get 2? Well, the square root of 2. Or you can do that. I have the square root of 2 over the square root of 2. So I multiply by the square root of 2 over the square root of 2. So I can rationalize the denominator. So that gives me 2 square root of 2 divided by 2. Those go to 1, so that's just the square root of 2. And so in this case, since cosine and sine are the same value, then secant and cosecant are going to be the same value, which is the square root of 2. And cotangent is the reciprocal of tangent. So 1 over 1 is still 1. Yeah, no, we already found those points. And so they went and found that x is square root of 2/2, which is the same as the y value. And so cosine and cosecant, cosine and secant, and then tangent and cotangent. So once we know these ordered pairs already, then finding those exact values is just a matter of figuring out which quadrant we're in and what angle in that quadrant. Please realize that when we talk about reference angles is that angle between the x-axis and the terminal side. So this reference angle is 30 degrees. So it's going to have all the same trig functions as 30 degrees, only we have to consider what quadrant we're in. That'll determine the sign. So the only ones we really need to know are these up here, and it just depends upon where we are and which quadrant we're in tells us what sign we need to use. Okay, so they're asking us to multiply those together. That's what that is saying. So the cosine of 45, which is a square root of 2 over 2, because we already calculated that, and the sine of 270, well, that's down here, and the coordinates of this point is 0, -1. So the sine is the y value, so that's -1. So a -1 times the cosine of 45, so that gives us a negative square root of 2 over 2, right? Everyone see how I got that? I did. Put my chat back up. Okay. So next thing. You know what? No, I need this, so I'm going to leave it up. Cotangent of pi over 4. Pi over 4 is 45 degrees, so in cotangent is y over x, which is 1. So in this case, the cotangent of pi over 4 is 1. So I'm going to erase this up here. So I have 1, and we're subtracting the cosine of 3 pi over 2. Well, 3 pi over 2 is the same as 270 degrees. And so that's down here, and that's a 0. So that's 1 minus 0, which is 1. Cosecant of pi over 4, well, we already determined what the cosecant of pi over 4 was, and that's the square root of 2. So we're going to do the square root of 2, and we're going to square that, and we're going to subtract the secant of pi. Well, pi over here is the point -1, 0. And secant is 1 over cosine, so it's 1 over the x value. So that's going to be 1 over -1, which is a -1. So it's going to be minus a -1, which ends up being +1. So the square root of 2 squared is 2, and 2 plus 1 is 3. So the answer to letter C is 3. Oops. What happened? Okay, there we go. Hopefully it's going to do it now. There we go. Is that what I got? Yeah, negative square root of 2 over 2. I worked it down here. And then the next one is you get 1 minus 0, which is just the 1, which is I got there. And then this one, the square root of 2 squared minus a -1, which is 2 plus 1, which gives us the 3. Any questions on this? You're saying, how can it be so easy? Well, because it's confusing sometimes. Where am I going? What am I doing? And I've got this mess up here that you have to navigate if you're using my diagram. And so we found these already. The exact value of the 6 trigonometric functions of 60. Well, that's dealing with this point here. So I'm going to erase some of this stuff. Actually, I can probably do with erasing most of this stuff and just rewriting back what I need. So I'm going to get rid of this up here. All right. So 60 degrees is that point. And so they want the cosine, I mean the sine of 60 degrees is the y value. So that's the square root of 3 over 2. And cosecant of pi over 3 is the reciprocal. So that's going to be 2 over the square root of 3, or 2 square roots of 3 divided by 3. I expect y'all to be able to convert this pretty quickly to where it has a rational number in the denominator instead of a irrational number or square root. Cosine, what?
Well, thank you for saying that. So in that case, could you like simplify how you got to that, sir?
Okay, so 2 over the square root of 3, all I do is multiply the numerator by the square root of 3 and the denominator by the square root of 3. Because the square root of 3 times square root of 3 is the square root of 3 squared, which gets rid of the square root symbol. So now I have a rational number down here. And in the numerator, I add 2 square roots of 3. So I move my radical from the denominator to the numerator by multiplying the numerator and denominator by that radical.
Okay.
Just be glad it's not in the 5th degree. Okay. So the cosine of pi over 3 is the x value of that point, which is 1/2. And so the secant is the reciprocal of that 1/2, which is 2. Tangent of pi over 3 is sine over cosine, or x over y over x. So that's going to be the square root of 3/2 divided by 1/2. Well, one way of because I know how fractions work, this is easy for me. But I can rewrite this, my numerator, as 1/2 times the square root of 3 divided by 1/2. And I'm always multiplying by 1. So I do it times 1 down there. Now these 1/2 go to 1, and that just leaves me the square root of 3 over 1, which is just the square root of 3. Now, when they show it, they just show going from this straight to that. They don't show the trick I do here. Or you're dividing by a fraction, so that means I'm going to multiply by its reciprocal. So square root of 3/2 times 2/1. The 2's go to 1, and I still get square root of 3. But when the denominators are the same, those can just go away. So if this was 7/2 down here, then this would be square root of 3/7. But it just becomes square root of 3. Now, cotangent is the reciprocal. Cotangent is the reciprocal of tangent. So the reciprocal of square root of 3 is 1 over the square root of 3. Multiplying numerator and denominator by the square root of 3, you get the square root of 3 divided by 3. So what I did there is I had 1 over the square root of 3, and I multiplied by the fraction square root of 3 over the square root of 3. I multiplied by 1. I'm always multiplying by 1. To change what things look like, I'm always going to multiply by 1, so it will change what it looks like. 1 divided by the square root of 3 is the exact same number as the square root of 3 divided by 3. They're identical. And that's what they did. So you figured out where the 60-degree angle is, and that's in the coordinate on, the coordinate for the unit circle. See, let me back up. What they're talking about here is finding these values based on the unit circle where the radius is 1. And this is a 30-60 degree triangle. And so that's how come we have these measures here. And the 30-60 degree right triangle I use, the hypotenuse is 2 and the shorter side is 1. So it's 1, 2, and 3, but we take square root of 3. Because what's happening here to do this, if you have the isosceles triangle, the equilateral triangle, all 3 angles are 60 degrees, but if I take half of it, then this angle becomes 30 degrees, and this side is 60 degrees, and this is 90 degrees, and this length here is half of the entire length. So that's why I say this length is 2. So when I take half, I get a whole number. And then I would do a Pythagorean theorem. So 2 squared is going to equal 1 squared plus that missing side in here squared. And so you end up with 4 equals 1 plus b squared, or 3 equals b squared. And I take the square root. And since I'm dealing with a length, I don't worry about the negative square root. So this is a positive square root of 3 equals that length of side. So that's where we get 1, 2 square root of 3. I play with numbers all the time. And this is actually from when I taught geometry. Feels like such a long time ago. Okay. So we move on. And so sine was the square root of 3 over 2. And cosecant is 2 times square root of 3 over 2. See, they showed the reciprocal here, 1 over it, which is you just end up flipping the fraction. And then you rationalize the denominator. And then cosine was the 1/2, and then you flip that fraction, take the reciprocal, which is just flipping the fraction till it's 2. And this over this, the denominators are the same, so those go to 1, and you're just left with the square root of 3 over 1, which is square root of 3. And then the reciprocal of 3 is, well, they did y over x, and for cotangent, they did x over y. But I like to say that it's the reciprocal of the x, which is 1 over the square root of 3. I mean, the reciprocal of tangent. And so that's how we get that. Okay, so this is going to be the same thing. We're going to get the same numbers except for except the sine and cosine are going to be reversed. And that means the tangent and cotangent are going to be reversed.
Sir,
What? Yes.
would you mind putting on the closed captions, please?
Okay, I can. Oh, hi, Robert. Scott, I'm sorry. Yeah, you go by Scott. Oh, where? Oh, it's over here. Sorry. There we go. There we go. I think that did it. Did that do it? Okay. Oh, dadgummit. Okay. So it's showing up because it's not showing up for me.
Yes, I see. So it's showing up, so it's not showing for me. Yes. Oh, I see. So it's showing up, so it's not showing. Yes.
Okay.
Yeah, it's showing up.
There it is, all the way down there. Okay. Now, yeah. So the sine of 30 is the same as the cosine of 60. Because our x and y here are reversed of our x and y here. There it goes. Okay. So our point now is the square root of 3 over 2 and 1/2. So sine is the 1/2, which is the same as the cosine of 60. And the cosecant is a reciprocal, so that's going to be 2, the cosecant. And the cosine is going to be the square root of 3 over 2, right? Square root of 3 over 2, that's our x value. And the cosecant, I mean, the secant is going to be the reciprocal of that, which is a square root, 2 square roots of 3 over 3. And, tangent is sine over cosine, or x over y. And so that's going to be the 1/2 over 3 square roots of 2, which simplifies to 1 over the square root of 3, which rationalizes to the square root of 3 over 2. Square root of 3 over 3. Sorry. And then the reciprocal of this is the reciprocal of 1 over the square root of 3, which is just the square root of 3. Or cotangent is x over y. And because the way fractions work, the two denominators are the same, so those go to 1. And so you just have the square root of 3 over 1, which is square root of 3. And so they built up a little chart here that talks about those. These are the ordered pairs, sine and cosine, but it's the cosine is the x values and the sine are the y values for each of these angles on the unit circle, because we're always talking on the unit circle. And then they built up the tangent, cotangent, secant, and cotangent. Cosecant, yeah. Any questions here? Yeah, this is in the PowerPoint that I've already posted in files. You have a rain gutter that's to be constructed of aluminum sheets 12 inches wide after marking a length of 4 inches. Each angle, 4 inches from each edge. The length is bent at an angle of theta degrees. The area of the opening may be expressed as a function of theta, where the area on theta is 16 sine theta cosine theta plus 1 times cosine theta plus 1. So they give us three angle measures to put into that formula. So you have 6, whoa. You have, I didn't change, I thought I changed it. So you have 16 times the sine of theta times the cosine of theta plus 1. Right, so you're going to add 1 to the cosine of theta, and you're going to multiply that by the sine of theta, and then you're going to multiply that by 16. So they want to know for when theta is 30 degrees. So it's going to be the sine of 30 degrees times the cosine of 30 degrees plus 1. All right, 30 degrees. All right, that the coordinates for that point are the square root of 3 over 2, 1/2. So the sine is the y value, so that's going to be 16 times 1/2. And then inside here, it's going to be square root of 3 over 2 plus 1/2. I mean, plus 1. So we have the square root of 3 over 2 plus 1. All right. So I'm going to go ahead and do this multiply out here and say it's 8. And we have the square root of 3 over 2 plus 2 over 2. You see what I did there? I made 1 be a fraction with a 2 on the denominator so I can add these two things together. So this becomes 8 times the square root of 3 plus 2 divided by 2. And then multiplying by 8, that 2 goes to 1, this 8 goes to 4. So this is just 4 times the square root of 3 plus 2. And do we have inches? So that's going to be inches squared. And so I would punch that in the calculator. Do they want us to express it in terms of Do they want decimal number? I'm assuming they're going to want decimal numbers. So they're going to round to the nearest, I think, degree or the nearest inch or half inch, maybe, or the nearest, or, oh. So they did the same thing here. Oh, they went ahead and multiplied. Yeah, they got rid of that. So it was 4 square roots of 3 plus 8. So they got rid of the, yeah, I should have done that myself. And they, let me see, how many decimal places did they go to? They went to 2 decimal places. So that's going to be approximately, and they didn't tell us they wanted 2 decimal places, which is shame on them. So that's square inches, because this gives us area, and area is in square units. So yeah. And they wrote out square inches where I used the shorthand way of writing square inches, inches squared. All right, now for what they want, 45 degrees, we're going to do the same thing. The sine of 45 is the square root of 2 over 2. The cosine of 45 degrees is the exact same number, square root of 2 over 2, and then we're going to add 1. And it's being multiplied by 16 out here. Well, this multiply gives us the 8 square roots of 2, changing this to 2 over 2. So my numerator becomes square root of 2 plus 2 divided by 2. And this becomes, so multiplying by the 8 in here, that goes to 1 and that goes to 4. So now I have 4 times the square root of 2 times the square root of 2 plus 2, and multiplying in by the 4 square roots of 2, we end up with square root of 2 times square root of 2 is 2, and 2 times 4 is 8. And then 4 square roots of 2 times 2 gives us 8 square roots of 2, and then we would punch that into the calculator to find out how many inches squared it is. And so they set it up the same way I did, only I didn't write it out. I put down with the sine of 45 and the cosine of 45, and they didn't show all the steps to get to here. And then, oh, they got 19.31. They rounded to the second decimal place again. And now with sine, since with sine and cosine of 30 and 60 degrees, I mean with sine and cosine of 30 degrees and 60 degrees, the sine and cosine get reversed. So instead of using 1/2 for sine, I'm now going to use square root of 3 over 2 for sine. And instead of using square root of 3 over 2 for cosine of 60, it's going to be 1/2. So it's going to look very similar to this, but these two numbers are going to be reversed. Okay. And so we get something different. And so that's going to be 3 halves over there we're multiplying by, right? because 1/2 plus 1 is 1.5, which is 3/2. So we're multiplying by 3/2 times square root of 3/2. So that gives us the square root of 3/4, and we're multiplying that by 16. So that's going to be 4 square roots of 3. Oh, 12 square roots of 3. Why 12? Oh, I know, because we're multiplying by 3 out here. Because I'm multiplying this times the square root of 3/2. So that's why I dropped that 3 there. So that's why it's a 12. Okay. I get in a hurry. And I make clumsy mistakes. So this is approximately 20.78 inches squared. Interesting. So the larger the angle, the larger the area. All right, the use of symmetry provides information about certain integer multiples of the angle 45 degrees, which I've already discussed, this symmetry here. Okay, we have point symmetry, and then we have symmetry with respect to the y-axis and symmetry with respect to the x-axis. So depending upon the symmetry we're talking about, either one sign changes or both sign changes. So if we're talking point symmetry, then the point up here in the first quadrant it has point symmetry with the point down here in the third quadrant, which means all we're doing is changing the signs are on our x and y. Same thing with the second quadrant and fourth quadrant. We're just changing the signs on our x and y. If I'm looking between the fourth quadrant and the first quadrant, then that's symmetry with respect to the x-axis, which means we're changing the sign on the y. And same thing over here with these things in the second and third quadrant. Now in the first and second quadrant, the symmetry with respect to the y-axis, so that means the x values change sign and the y values remain the same. Same thing down here between the third and the fourth quadrant. It's the x values that change sign, but the y values keep the same sign. And so that's the symmetry we're looking at. And I had discussed that earlier. So 5 pi over 4. So we want to look and see where 5 pi over 4 winds up. Which quadrant does that wind up in? Oops, too far. Oops. So we have 5 pi over 4 means we're going more than one pi, and then we're going to go another 45 degrees. So that's this angle over here. And so that's the coordinates of this point is going to be the square root of 2 over 2 negative, and negative square root of 2 over 2, because it's a 45 degree angle. It's one of the 4 45 degree angles we talk about. And so the sine and the cosine are going to be the same, and they're both going to be negative. So this is negative square root of 2 over 2. 135 is this 45 degree angle, 145 degrees. And it's going to have square root of 2 over 2 and square root of 2. Let me write it right. square root of 2 over 2 and square root of 2 over 2. But because we're in the third quadrant, the y value is positive and the x value is negative. So the cosine is the negative square root of 2 over 2. 315 is going all the way around over to here. And because of the point symmetry with this point over here, I'm just going to change the signs. So it's going to be the same numbers, except instead of a negative square root of 2 over 2 for the x, it's going to be a positive square root of 2 over 2. And the y is going to be a negative square root of 2 over 2. And cotangent is the x over y. So I have square root of 2 over 2 over a negative square root of 2 over 2, which is a negative 1. Now, interestingly, a negative pi over 4 is the same, has the same terminal side as the cotangent. I mean, as the cotangent. Yeah, that was negative 1. Is so it has the same term. So it has the same coordinates for on the unit circle. Because a negative 45 degrees just brings us to the same as the 315 degrees. They have the same terminal side. And so we use the same numbers here for the cosine. The cosine is the x values. So that's square root of 2 over 2. And guess what? 4 pi over 2. Well, that's 8 pi, over 4. 8 pi over 4 plus 3 pi over 4. Because we go, now that means we go around, because now that's going to be 2 pi plus 3 pi over 4. So I go around once, and then I go 3 pi over 4, which is going to be over here. So that's the same terminal side as 135 degrees has, which is this coordinate, these coordinates on the unit circle. So that'll tell us what the cosine and sine are, that are the trig functions. So sine is the y value, so that's square root of 2 over 2. So it's just a matter of finding out where you wind up. Okay, it's not so much what degree we're talking about, it's what's the terminal side. Where's the terminal side going to wind up? Because as you can see, sometimes we get something that's greater than 360 degrees. Sometimes we get stuff going in the wrong direction or negative. It's not wrong direction, it's just opposite direction that we're used to. So it's just a matter of finding out where our terminal side winds up and finding the appropriate sign for the x and y for that point, and then find the trig function based on that point. And so, yeah, I said that one was negative square root of 2 over 2 because the y, which one was that? Oh, that was this point here. Okay. And then 3/4 pi winds up here. This terminal, so the point on that unit circle is those coordinates. And so the cosine is a negative square root of 2 over 2. And we talk about these coordinates here for letter C. And for 7 pi over 4. And what word are they asking for? The cotangent. The cotangent is x over y. And so that just winds up being -1. All right, and so this same point corresponds to negative pi over 4, and we cosine is the x value, which is a positive square root of 2 over 2. Yeah, one of the trig identities we have is the cosine of theta equals the cosine of negative theta. So the cosine of 45 is the same as the cosine of negative 45. Okay. Where are we? Now we can use symmetry to provide information about the integer multiples of, all right, I already talked about that, about how the symmetry works. Okay, so you're either changing the sign of the x going across the y-axis in this situation or this situation down here, or you're changing the sign and same thing over here, or you're changing the sign of the y value if you're crossing the x-axis in these two situations and these two over here as well. Okay. My eye is itching, sorry. Now, so and that's what happens with the integer multiples of 30 and 60. And some of those multiples wind up on the other. But anyway. So cosine of 210 degrees. Well, 210 degrees is in the third quadrant. And let me see. So we're talking over here with this one. So that would be, oh, where'd my mouse go? There it goes. Okay, so this point and this point have symmetry across the origin, and so the numbers will be the same except they'll be opposite signs. So negative square root of 3 over 2 and -1/2. And so they were asking for the cosine, so that's going to be the x value, which is the negative square root of 3 over 2. So negative sign just means we're going to go in the opposite direction here. So sign will be down here. So whatever the sign was up here, which was a positive 1/2, I believe. So now it's going to be a negative 1/2 down here. I remember that correct? No, that was wrong. That's going to be positive square root of 3 over 2. So this will be a negative square root of 3 over 2. I remembered wrong. And then tangent of 5/3 pi is here. Is this angle coming all the way around to here. And so this point, let me go back to this diagram, is the point is 1/2 negative square root of 3/2. Okay. So knowing those quadrantial angles and all these different angles here, and where's that chart? And filling in this chart, understanding what's going on there, that will help you with these. So going in negative 60 degrees is the same as 30 degrees. I mean, 300 degrees. So here are the X and Y values for the point on the unit circle for 300 degrees. And they wanted sine, which is the Y value here. Tangent of 5/3 pi. So 5/3 pi, isn't this it? Yeah, that's weird looking 5. But 5/3 pi so that's the same as a negative 60 degrees. And so tangent is y over x. So negative square root of 3/2 divided by 1/2, which is the negative square root of 3. Yeah, I play with numbers all the time. What can I say? And cosine of 8/3 pi. Where's 8/3 pi? Well, that's more than once around. Once around the circle. Once around the circle is 6/6 pi, because that's 2 pi. And then we're adding an additional 2 pi thirds to get the to get the total of 8/3 pi. So this is one circle, and then we do the 2/3 pi, which is the 2/3 pi is back up here somewhere, is in the second quadrant, and that's this ordered pair. And they're asking for cosine, which is the x value, so that's going to be a negative 1/2. Okay. Yeah, so that was a negative square root of 3/2. And this one is the same as 2 pi over 3, because we take out the full circle. You can take out the full circle and then here's our angle that we're dealing with. And so that's how we get the negative 1/2. And we're at time. And this is just using the calculator. So you just punch numbers in the calculator. I don't test you on this. So, but they do ask you to do it in the homeworks. So that's just punching it into the calculator. And if you have issues with that, then let me know. Okay. Hopefully the graphing calculator, I mean the scientific calculator you have has pi, the symbol pi. So you can do that without using 3.1416. Okay. Set the mode to receive degrees, and then round to 2 decimal places. And on this one, and then set. Most calculators do not have a secant key. And so remember me saying that secant is the reciprocal of cosine. So you do 1 divided by cosine of 21. And then round it to 2 decimal places. And then setting your calculator to receive radians, so you don't have to convert this to degrees. and go from there. And we'll start with this slide next time. So I'm going to start sharing because I'm being selfish. Okay. Oh, and I haven't had my picture up. Oh, last one. Okay. Any questions?
Sir, you have a this class is like a physical class that is Zoom for now, right? But you mixed like the Zoom only class and the physical class?
Yeah, this class is a dual modality class.
What do you
That
mean?
means for this class, I think 10 of y'all are face to face in the classroom, and the remaining 3 are remote. So
If we're a face-to-face person, can we just join one of your Zooms instead? Or does it like is it interchangeable for the physical people? Or is it like only for-
technically, we're not supposed to do that. This class is small enough, however, I'm not going to have an issue with that. But I will be on campus, and so I will be doing the class in the classroom, and so there'll be a Zoom. So each classroom is fitted or is being fitted with a camera and microphones. So whatever I'm doing up front of the class will be here in my picture here. Ooh, there we go. Okay. I'm gonna move my Zoom off of that. So I need to, I've been told, but I need to make sure I remembered correctly. I'm thinking they're not gonna be particular about it. I know because of COVID, people are some, even if they bring everything back on campus, there are people who are going to be uncomfortable with coming on campus. So, yeah. Okay.
Personally, I can't wait, sir. I cannot wait. It's been 2 semesters of my college experience, and I haven't stepped foot on campus. It's a little weird. It's a little weird.
Yeah, this is my third. Well, wait a second. When did we first go? So that was
August
in the
2020.
spring. In the spring
Yeah.
of 2021 is when we went remote.
Didn't we go remote August? The fall 2020? Fall 2020 we went remote.
Well,
Because I graduated 2020, and then I went straight into remote classes.
Okay. So in the fall, the spring of 2020 is when we first started going remote.
Okay. So spring of 2020.
Yeah. So I've been doing this for a year and a half,
That's crazy.
which is driving me nuts.
Preach it.
Because I like to see people's faces when I'm teaching, and most people don't want to turn on their camera, because after I dismiss the class, there's sometimes just 1, maybe 2 people who are still there and don't respond to me when I ask them if they're there. And so then that's what happened with my 8 o'clock class this morning. I had somebody stay after class, and like we're doing right now, class is over. So if you want to leave, you're quite welcome to leave, unless you have questions for me. But then everybody was gone except for this one person. I said, "Do you have a question for me? Are you there?" And so I just ended the session because they had it on, but they weren't there. Okay, well, goodbye. Y'all take care. If you have anybody has more questions for me, I'll be here for a little bit. Andrea, if you're talking to me, you're muted.
Yes. No, sorry.
That's okay. Uh-oh. Yes. That's good. Okay.